Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and a very good evening. Today we'll be again using SAS, and I will also use another software, that is Winpepi. I will talk in some detail about Winpepi also. Now, today we'll be doing frequency analysis by using SAS software. So the data is basically a research trial conducted on tuberculosis in field in 2 cities. So that was my project activity, where we carried out this research in 2 cities. So we applied a diagnostic test and we found some positive animal and negative animal. So the data from the animal and area is collected comprehensively. I will show you the data. So you will see, after collection of the data, how the data is handled, I will let you people also know that. So we'll be looking into a very good epidemiological data or survey data. So we'll be doing, I already said, frequency analysis. How many were negative animal and how many were positive animal for each category, and each variable is further grouped into 4 or 5 groups. So we'll be looking into that. So I'll let you know how I made those groups, and we'll be doing frequency analysis. Frequency analysis will generate a total number of negative animal for that very category and positive animal for that very group, and then the percentages, and then at the end for all the groups the chi-square test will be there, that will help us understand whether between the groups there was significant difference or not. And then I'll be using another software. I'll be constructing the Word file. I will let you know how to enter the data and make a table. Then after constructing the table, I'll be using Winpepi software. That is another excellent software developed by a Spaniard. I lived in Spain for 1 year, so I love Spanish people. Unfortunately, few years back, the professor died actually. He developed this software from scratch. So I will let you know what kind of statistics I compute by using Winpepi, and we will compute that statistics here, and how that will be helpful in our quality research output, quality publication. So one of my professor used to say, a very good work poorly presented is a poor work. An average work nicely presented is a good work. So let's go for it, and let's see how we can make good work out of the data. So let's start it and do our analysis by using SAS software. Let's start our frequency analysis by using SAS software. So we need to enter into SAS On Demand Studio. SAS now. Click launch. So it has opened up. We'll be using this file, Buffalo City's final, for frequency analysis, and here is that file. It is already open in work library. The file is open here already. So into edit in the code section, enter edit. Now we can enter 2 times, and here we will write our code. First, let us see the file, Excel file. Now, this study was conducted on buffaloes in 2 cities. A disease was a survey was conducted in 2 cities by using a diagnostic test, and here are the results of the test: 0 mean negative and 1 mean positive. There will be one somewhere. Yeah. So 1 mean positive and 0 mean negative. So the diagnostic test was applied on the buffaloes, and the disease was diagnosed. As much information as possible that was recorded. Actually, it was recorded 1 year, 1.5 years, or what age was 4 years, 3.5 years, and then they were grouped. Grouping was done. Here is the grouping of age. So we'll be doing frequency analysis for age groups, and sex. So we have seen the data. The data is here. Okay, you can do your grouping. How to enter the data? You can see from here. Top row is variable. There is no space between the letters written. Okay, total animal group. This is how you should write. Combination. The alphabet has to be 8, not more than 8. Try writing not more than 8. But here, now the software pick even more than 8, but generally we don't write more than 8 alphabets for each variable name. Anyway, so here is that data, and we will be using it. Now, I have already did this analysis, so the syntax is saved. I'll be putting this syntax into the SAS online system, and let us discuss it. Now, as previously I told you that first thing we need to do is we need to sort the data. Which data? This is the data file. That data file is indicated. This data file, the data has to be sorted. How it has to be sorted? Because we want to compare age group, whether there was any significant difference between age groups in positive animals or not. So we are going to sort the data age group and result. And then we'll be doing frequency analysis. The command is proc-frec data. This is the data which this command should use. And we need to generate the tables age group into result. This will generate the tables. I have already made a table in this Word file, so we'll be entering data here, results here. Last time we did not write this run command. You can write it or you can don't write it. It makes no difference. So let's run it. It will sort the data and generate the table. So here the table is generated. You can see this table, and here the chi-square is applied. Mental-Hensel chi-square is more stringent test. Simple chi-square is also applied, and likelihood chi-square is also applied. So the difference is non-significant. The value is greater than 0.05. Okay. So anyway, we need to put this data into the table we have constructed. So the n is 387. Now here in this table, some information is given. The first one is frequency. We are doing frequency analysis. Second one is percentage. This percentage is overall percentage. This is row percentage at third number, and this is column percentage in this way. Okay, so we are concerned with percentage that is in the row. That percentage will be noting down in our Word file. So 387, 98.72, 98.72. Negative, positive are 5, and its percentage is 1.28. Next is 405 are negative, and 16 are percentage is 96.20, 96.20, and positive are 16, and its percentage is 3.80. Now the chi-square is indicating non-significant difference. Remember this. So this is how the frequency analysis is done. Let's do it for sex as well. And we need to sex group. So see here, there's sex group. Here the English alphabet is written, so this software will pick up the value, numeric value given. So 1 is for male and 2 is for female. So we'll be doing this frequency analysis. So we'll make sex group into result and sex group result. This is our sort command, and this is our frequency command. Ask it to run, it will run and generate a table. So here the table is generated. The chi-square values are non-significant. You can see here. So we need to write these values in the table. Let's fill up the table again. 1.28. I told you this, we need to write this percentage. This is row percentage. And 2.72. The values are 28. And the percentage is 2.72. You can put this chi-square value underneath in each you can write here this chi-square value, and this is p-value. Okay. So you can write. You can do it again the other one, and you can write p-value and chi-square value there as well. Now, it has done quite a lot of work. So we are done with frequency analysis by using SAS. It has given us the results. The results are not significant. The values are generated. So this is how we do frequency analysis in SAS. So you can do analysis for all other variables and generate the tables like by using the same command. You need to make change here by variable. And okay, one thing more, you can add here area. You remember we actually we conducted these studies in two cities. So you can use by variable, and in area it will generate results for. Now you need to sort the data according to area also, and then you can put by variable that how the age group, the differences were significant or non-significant in one city or second city. So this will generate those tables. So here the tables are generated for Faisalabad city. This is a frequency table, and here are the chi-square results. And this beneath is for Pokhara city, another city, and here is the table. You can construct this table, add the values as we have added previously, and here you can see the difference is significant, 0.0471, and even likelihood is also significant. So at Okada, the difference between groups is significant. Okay, so you can use these results accordingly. Okay, so we are finished with frequency analysis by using SAS software. I hope we have understood it very well. So this is how we do frequency analysis by using SAS software. We are going to use another software to make this table more meaningful and beautiful. We are going to compute 95% confidence interval for each age group, and for male and for female. Okay, so let's do that, and for that I will be using Winpepi software. So here is Winpepi software. Now this is how it opens up. Now this is actually version 11.65. So let's use this software and do our data analysis. I'm using the describe component of this software, and I'm going to click on the appraisal rate. So here we can write the positive percentage 128%, and the total number 87 plus 5 392. So here is 1.28. This confirms that our total was right, and this is the p-value, mid p-value. This we need to write here. Second is 3.80, and total number is 421. So 3.80, 421. This value we will copy it and paste it there. Mid p value. So I have computed this 95% confidence interval. Now what does it mean? It means that if the same study is conducted in the same area by anyone or by the same person, there is likelihood that the value of positive animal will fall between the chances are that the value will fall between, the percentage value will fall between 0.47 to 2.80 for this very group, and 2.27 and 5.97% for second group. So this indicates this. Another thing which 95% confidence interval indicates is that if these values, they overlap with each other, that indicate there is a non-significant difference between them. So there is a non-significant difference. The 95% confidence interval also indicates this one. Chi-square also indicated a non-significant difference. Okay, so same is here, and chi-square also indicated non-significant difference. So this is how the results are interpreted. One more thing, that is, we need to do another analysis, and that is, we need to go back and go and compare command or compare component, and we need to click at categorical data to X table. Now here you can put first value for positive 5 and then negative 387, 16, 405, 4, 221, and 3, and 51. So this is 2 into K table, nominal data, click it run. So it has given us, Pearson chi-square has given us non-significant difference, 0.053. So here is also 0.053. This is Pearson chi-square test, okay? So the difference, both software shown us that the difference is non-significant. What else we can get? These are different odd ratio between 1 and 2, 1 and 3. It calculates different odd ratios. That is excellent. That is the beauty of this software. So we can see whether what is the odd ratio. This is what we call crude odd ratio. There are two kinds of odd ratio. One is crude odd ratio like this one, and there is log odd ratio that is done in logistic regression analysis. Okay, so here it also compute odd ratio. You can put this odd ratio as well. Here the odd ratio is taking the first group as a control group, and then the software has compared second group with the first group. The odd ratio is this, and you can see the odd ratio between 1 and 2 here as well. So this is 1 and 2, this is 1 and 3, and you can see 1 and 3 odd ratio below as well here, and 1 and 4 here. But it gives us other odd ratios as well between 2 and 3, 2 and 4, and 3 and 4. So you can use this odd ratio as well. It's all up to you. And then we need to click at the second component, compared to two variable. Yes is 0 and no is 63. And 2.7, yes is 28, yes is 28, and no is 1001. We will ask to run it. And here it has given us odd ratio, but this odd ratio is 0 because we have a 0 value. If there is a 1 here, then 1.56. Now we need to go again into compare to, and now we need to click into rates with no individual denominators. For example, prevalence in this table, put it into 100, make it 100. Now yes is 1 and no is 63. and here yes is 28 and no is 1001. Now it will compute the odd ratio. Now here it's a 1.76. You can put this odd ratio here, 1.76. Now what does this indicate? It indicates the chances of infections are 76% higher in female than male. This is what the odd ratio indicates. So I do hope we had a great learning. If you have any question, you can write in the comment on the video, and I see all the comments and I will respond accordingly. Let's hope everything was good, and anyway, I'll be there to help you people. If you have any question, you can ask anytime. Thank you very much. Next time, let's see, we'll be doing another data analysis by using SAS software. See you next time, and Allah Hafiz. Goodbye. Thank you.